In today's lesson, we are going to look at converting between standard and vertex form. So we've kind of looked at converting from standard to factored form. Now we're going to look at converting from standard to vertex form. So by the end of this lesson, we will have been able to kind of convert between the different forms of a quadratic. Right? In the previous lesson or previous unit, we looked at how to basically determine the vertex from the factored form, which we also looked at in the previous lesson. We looked at how to get the factored form from standard form, and now we're going to look at standard or vertex form from standard form. So just as a warm-up, we want to convert the following vertex form to standard form. So a way we can do this is we can break apart this bracket, x minus 3 times x minus 3. So we can expand this, right, using our distributive property. Oh, forgot the minus 8. Use our distributive property to expand this, or the FOIL method, we might call it. Rainbow method. So x times 3, or negative 3 is negative, or x times x, sorry, is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. Minus 8 is still on the outside. We then can collect some like terms on the inside. X squared minus 6x plus 9 minus 8. We can apply this factor in. So it becomes 4x squared minus 6, not 6x, because it's 4, sorry, is applied to everything. So we get negative 24x and plus 36 minus 8. So then we can collect our like terms at the end here. These two terms at the end. 4x squared minus 24x plus 28. So that's going from vertex to standard form, right? So that is just expanding. Now we want to think about, how do we go backwards? How do we go backwards from the standard form to the vertex form? Because maybe we want the vertex form, right? Maybe we want to see or determine what the vertex is from the standard form, right? We don't want to go into the factored form route. So we need to come up with a method, or we need to learn about a method about how to kind of convert backwards. So how do we go backwards? Like we just said, that's our goal. And the way we can go backwards is through a method called completing the square. So this may have been something you looked at in grade 10. It is going to kind of just involve a little bit of an understanding of some factors, but other than that, it might be considered its kind of own kind of concept. Right. So the steps to completing the square. The first thing we want to do is put brackets around the first two terms. We are then going to factor out the number in front of the x squared. So we're going to common factor the first two terms, and the value that we take out is going to be the value that's in front of the x squared. We're then going to look at the last term in the brackets. We're going to divide it by 2 and then square it. So this little portion here is what we call getting our magic number. From there, we're going to add and subtract that term behind the last term in the brackets. So we're just going to add and subtract it in the brackets. We're then going to move the negative term outside of the brackets by first multiplying by the a value. Then we're going to simplify the terms outside the bracket and factor the perfect square trinomial. Right, so this is going to require a little bit of understanding of factoring, as well as just some other general calculations. So again, that was a lot of steps, that was a lot of words. Let's kind of go through and show what we're actually trying to do. So we have our standard form equation, y equals x squared plus 8x plus 5. So our goal, or what we're going to do first, we're going to put brackets around the first two terms. X squared plus 8x is on the inside of the brackets, and we have plus 5 on the outside. So now the next step is to common factor. There is no value in front of the x squared, so that's fine. We don't have to do anything else. What we can do, though, is now we move on to the next step, and that is finding our magic number. So to find that magic number, we take the second term in the bracket, this 8. We're going to divide it by 2, and then we're going to square it. So 8 divided by 2 is 4. 4 squared is 16. Once we find this magic number, we are going to add and subtract it after that last term in the brackets. So that 8x stays there, and then we have plus 16 and minus 16. We still have the plus sign on the outside. What we want to do as well now, the next step says we have to move this negative term onto the outside and multiply by the a value. So in this case, the a value would have been the value that we factored out of the first two terms. However, since we didn't factor anything out, technically our a value is an invisible 1. So that means when we take this negative 16 out, we're going to multiply it by 1, which doesn't really change anything, but again, it is going to be helpful to kind of know that step for when we have to do it with the other terms or with other examples. So I'm going to rewrite the bracket. Still the plus 16 is there. The minus 16 is on the outside. It's multiplied by 1, so it doesn't change anything. So we get plus 5 minus 16. I can simplify the terms on the outside. So x squared plus 8x plus 16 is or in this case, minus 11. Now, the last step, this bracket here, this bracket here is a perfect square trinomial. So because that's a perfect square trinomial, we can factor that. In this case, it's going to be x plus 4 squared. The plus 4 because of the square root of the last term of 16. And we have the minus 11. Now, if we do this correctly, if we use the right magic number, this will always be a perfect square trinomial in this bracket. Right? So as long as we find the right magic number, this bracket trinomial will be a perfect square trinomial, which means that we can use that kind of shortcut. And now we have our equation in vertex form. So we can see our vertex, we can see our a value, right? So we can know the transformations, we can graph this if we wanted to, based on what we've done before. So we're just going to go through and do a couple different examples just to kind of get used to this process. And if you saw this in grade 10, hopefully it should be a little bit of a refresher. So again, we're going to put brackets around the first two terms. 3x squared plus 12x. And the minus 7 is on the outside. The first thing we want to do now in this case is we want to factor out this 3. So we want to take out this factor of 3. So we're going to common factor that first bracket, and we're going to common factor by taking a factor of 3 out. We're only factoring the value out. We're not taking out an x value. So you're only common factoring a number. So x squared is left over plus 4x. Because if I divide 12 by 3, I get 4. And I still have the minus 7 on the outside. Now that we've common factored, I need to find, or I factored the first two terms, I need to find my magic number. So the magic number, I'm going to take 4, divide it by 2, then square it. So 4 divided by 2 is 2, 2 squared is 4. So now that I have that value, I can add 4 and subtract 4 inside that bracket. And the reason we add and subtract is because if I add a value and I subtract the same value, technically I haven't really changed anything, right? Because plus 4 minus 4 is just 0. So I haven't changed anything. I still have the minus 7 on the outside. And the next step then is to move that negative to the outside. However, it's a little different here because we have this a value of 3. So when I move the negative 4 out, I need to multiply it by the a value, or I need to multiply it by 3. So what that means is that when I rewrite this, the minus 4 actually becomes minus 12 on the outside, right? Because I had to reapply that factor of 3 that I took out. Now, when I go through and factor, this bracket should be a perfect square trinomial, which it is. So it's going to be x plus 2, square root of the last term, sine of the middle. So x plus 2 squared. And then minus 7 minus 12, we're at negative 19. So again, now we have our equation in vertex form. One last example, similar idea. Brackets around the first two terms. I'm going to common factor, or I'm going to factor out the value in front of the x squared, in this case the negative 5. So this becomes x squared minus 2x minus 7. I'm going to find my magic number now by taking, let's write out magic number. So I'm going to take that second term in the bracket, the negative 2, I'm going to divide it by 2, and then square it. So 1, or negative 1 squared, or just 1. So now I can take this negative 5, x squared minus 2x plus 1 minus 1. So that's plugging that magic number in. That minus 7 is still. We have that minus 7 on the outside. We are going to have to move this 1 to the outside. I'm going to end up moving this negative term on the outside, but I do have to reapply that a value, or that factor out front. So I bring it to the outside, I have to multiply it by negative 5, so it stays negative 5 at the front. X squared minus 2x plus 1. That negative 7 stays, but that negative 1 that we moved on the outside and reapplied that factor of negative 5 becomes positive 5. So I get negative 5 x squared minus 2x plus 1. And then we have negative 2 on the outside. This bracket, again, is going to be a perfect square trinomial. So we can take the square root of the first term, which is x, square root of the last term, which is 1, and the sign for the middle value to be the sign in our bracket, and then minus 2. So again, the whole idea is just about how we can get from standard form to vertex form, because that is another that is a more useful form to be graphing things or to look at. So again, just to make sure we know now how to convert between the different forms of a quadratic.